Good evening, everyone, and welcome to the September 14th Garden State Java User Group meeting for tonight. We're coming to you live from New Jersey. All of us on the leadership team here are representing various parts of the great Garden State. So we will get things going right away, as we always do. Give me 1 second here. Okay. 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 Okay, so the agenda for tonight, would like to, as we always do, thank our sponsors who make things happen for us here at the Garden State Java User Group. Talk about what's new. Introduce Ari Waller, who is represents JFrog, our platinum sponsor. So he will say a few words about what's happening at JFrog and also have an opportunity to participate in a raffle for a special giveaway. And then I'm going to introduce Neha Sardana, who will be our speaker tonight, and she will talk about Spring Security. And then we have our IntelliJ Idea giveaway, and you can see the link for the spreadsheet to enter your name and email address, and from there we will randomly draw a winner for that. So our platinum sponsors I mentioned is JFrog, and we thank them for being there for us and their sponsorship. And of course, Ari is joins us every couple of months for a giveaway and talk about what's going on at JFrog. So thank you, Ari. Our silver sponsor is Azul, and they of course they make their downstream distribution of the Java of JDK, and so I'm sure you'll hear from all these vendors on Java 17. Our partner is DevNexus. And then we have our per meeting sponsors, the JetBrains, who obviously provide the IntelliJ Idea giveaways, and also Jakarta EE for providing Crowdcast use for video conferencing. So what's new? Well, the big news today, and I'm sure you've seen it all over Twitter, is Java 17 is official today, and it's the next long-term support release. And so, if you want to give it a try, take a look at a lot of the news that's out there and what's going on. Of course, I have to do a shameless plug for my InfoQ piece that is out there and that talks about some of the two JEPs that generated some concerns within the Java community about the internal Java elements and also the security manager. So, and also we're on the FUJE OpenJDK 17 plus JUG tour. This will be 2 weeks from tonight. And we have Simon Ritter, who will be presenting are all OpenJDK distributions the same or something to that effect. It's on our website. So we look forward to that as well, 2 weeks from tonight. And just so we can, as a lot of you may know, we were supposed to be on the Quarkus World Tour tonight. It just didn't happen for tonight, long story. However, we're working with Red Hat to get that rescheduled for, we're hoping for our November meeting. So please stay tuned for all that update. And at this point, I'm going to stop sharing and introduce Ari Waller. Like again, he's manages the, I was going to say a dev advocacy, but Ari, you can let you introduce yourself. I keep forgetting.
That's okay. I appreciate the promotion. I'll let my boss know. That's awesome. Hey, hi, everybody. Let me go ahead and share my screen if I may. Let's see here. Cool. Can everyone see the screen okay?
Yep, we can see it.
All good.
Okay. Let me actually, that's kind of, okay, great. You can see oh, good. Okay. Something else popped up, which was like a slide of something else. And I was like, wait, still a challenge after a year. Hi, everybody. I'm Ari Waller, and I am the Meetup Event Manager for JFrog. And we are really excited to be sponsors for the Garden State Java User Group Meetup for 2021. I'll share just a little bit about who we are. JFrog is the DevOps software company best known for Artifactory, which is considered by many to be the gold standard for managing your artifacts and dependencies. And no surprise, it was also written in Java. I also know that some of you may have heard that JFrog and Docker announced a partnership in the beginning of 2021. And we want to make sure that the Garden State Java user group has the ability to take advantage of this by taking the Docker challenge. Besides the really awesome JFrog t-shirt that you'll be awarded for completing the challenge, it's a great way to try the free tier of the JFrog platform. And if you're working with Docker, as I know many of you are on a daily basis, that the cloud subscription for JFrog, because of the partnership I just mentioned, is capable of functioning as a pull-through cache for Docker Hub. And you will have there will be no rate limits on pulls from free or anonymous accounts. So hopefully that could be valuable for some of you. Now for tonight, the giveaway that we have is just for meetup attendees. So you have to be here this evening, and it's going to end right after the entry is going to be ending right after the meetup tonight. And this is a prize that's been very popular with the Java meetups, and that is a chance to win a pair of Beats Studio Buds by Apple. You can enter with the QR code or the bit.ly link that you see. And on the form that you fill out, you'll have an opportunity to opt in for the Docker challenge as well. So lots of neat things to get involved with tonight. And also a winner will be selected within 2 business days and then contacted by email. And once the winner officially accepts the prize, we will share the winner's name with the entire Garden State Jug community. So we're really excited about that. I'm going to ask if the link can also be dropped on YouTube, so those who are watching can join as well. And again, thank you so much. We're really looking forward to Neha's talk tonight. Talk to you soon. Thanks. But back to you.
Okay, thank you, Ari. It's a pleasure as always, and you're looking at my HTML code here, which we don't want to see. Okay. So anyway, so I'm happy to introduce tonight Neha Sardana. She is, one of the leaders that joined us. I guess at the beginning of the year. It's been so long. It's been almost a year since we've actually incorporated. As a nonprofit, so the time does fly pretty quick. But we obviously appreciate all of her support and assistance and the various tasks that we do. We meet once a week, so I just want to say that thank you, Neha, for doing this at the last possible minute. And so you should know that actually this presentation was delivered at the Spring One conference. I guess that was 2 weeks ago. And I think you delivered this at the TCF IT Professional Conference back in late March. So be good to see this one again. And also you're a VP at BNY Mellon.
Yep.
So with that, I think, okay, we'll change that for later. And we'll stop sharing and hand it over to Neha.
Thank you, Mike. I really appreciate, since the time I've been working at the Garden State Jug, it's my good time. I learn a lot from you guys. So thank you so much for giving me the opportunity. And I want to mention thanks to Ari, because of him, I've been able to use the Apple AirPods. So if you guys are wondering, you should definitely check out the raffle that's there. People are winning. So I definitely recommend that. Let me start sharing my screen. Hopefully everything is looking good. Can anyone tell me?
Looks good.
Thank you. Okay. So I recently presented this talk at the Spring One conference on Spring Security. The talk is about building layers of defense for your application using Spring Security Framework. So the idea came to me because I have been using Spring Security Framework for a little over 5 years now, and I'm comfortable using it. But a lot of times, I felt like even though we have a lot of examples and samples, like how to write the Spring Security code, we don't know what really is the underlying principles of security, and how to implement it, what exact interfaces are coming in between. So I try to justify with that, and also, like, there are a lot of things that Spring Security does which we may not be aware of. Our main focus always as a developer is writing good applications, and that's really true. But we also have to focus on writing security of our applications well, because there are hackers everywhere. So that was the idea of creating this talk and giving you some knowledge on both the security concepts and Spring Security fundamentals as well. So Mike already said so many things about me. I don't have to really use this slide anymore. But just to add a few things that I wanted to say, like, I have been writing Spring-based applications for almost all my entire career here. I've seen the framework going from before Spring Boot era, and now, as most of the new editions of Spring projects are added, I've seen the framework is very robust and it's good to use. My hobbies include, I love to travel, which I'm not able to do that anymore. So I'm just restricted here in my house. But I'm hoping to do that again. I practice yoga, which keeps me calm and composed during this good times we are living in these days. And I watch cricket. So I can talk about cricket a lot. If anyone has any questions, I hope you have them. So yeah, that's all about me. I have my GitHub link here. I'll also share the link to my code, which I'll have another link, specific link to my repository, which I'll be using as a code today. My LinkedIn profile and Twitter is here. I also write blogs. I have written one travel blog and a few other blogs, which you should check out on open source as well. So that's there. And I'm very active on Twitter, so I like what I share. So that's what. So let's look at the agenda today. So we have a lot of things to cover, and I'm very happy that I have enough time to cover here today, because it's not really restricted time. But I want to still go through each and everything, in depth, and we want to talk about everything. So we will start with the two basic concepts of security, which we can't really leave out, which is authentication and authorization. These are the wheels of security. One do not work without the other. We'll talk about the layers of defense that you can apply for your web application. We will think about the layers of defense as a castle building approach. So we will protect each of our gates with some defense mechanisms that we should apply. I'll also talk about Spring Security in depth, because we want to cover what interfaces are used to secure your applications and what are the important components in Spring Security and how the authentication framework authenticates a user. That's one thing that we want to cover up. We also want to know the common security threats that are out there. Since we don't really, as a developer, we don't really bother much about these, but it's actually a good practice to be aware of these common security threats. And we'll see how Spring Security protects us against these threats. So even though Spring Security is doing a lot of things by default, it's nice to know that you have the options to modify or protect. It's doing all these things by its own. So it's good to know that. We also talk about basic authentication. We'll cover JWT, OAuth, and OpenID Connect as well, just briefly. But we have a code as well to show you how it all works together. I wanted to end this talk with principles of application securities to solidify the understanding that we have gathered so far at the end. So that's the agenda going to be like. Basic prerequisites for this presentation: you should know Java. And you should know Spring Framework, so that I'll talk about some interfaces of Spring Framework which are essential here. I'm using Maven. No offense to Gradle or anything, but I'm more comfortable with Maven. I like Maven, so I'll show you the code with Maven. So that's the basic prerequisite. Although Maven is like an optional, you don't need to really be worried about it. So let's talk about security. So security starts with authentication. Authentication is all about validating your credentials, like a username or a user ID or passwords. So authentication is doing all, it's really identifying what you are saying, who you are is actually who you are. That's nothing else apart from this is the question right here. When we talk about authorization is actually the process to determine whether the authenticated user has access to a particular resources. So the next step after the authentication is done is like you are who you are, but do you have access to particular resources or not? Like I can be Neha, and I don't have, and I shouldn't have access to Mike's blog, and I shouldn't be able to update Mike's blog if he's writing anything. I should be able to given the read access so that I can read his blog, but I shouldn't have an access to update his blogs. I don't make accidental changes or anything. So it verifies your rights and grant you access to certain resources like information. It can be database as well. It can be files or anything like that. So authorization usually comes after authentication, which will confirm to your privileges to perform any action. So now let's see the layers of defense. So when we talked about the layers of defense, we talked about the castle building approach. So the idea is to have security at every step before you reach the end layer of your application. So the first step is to prevent your application at the network firewall level. So let's say you have an application, you can protect your application and it's bombarded by a lot of requests. So the network firewall can actually protect a bombardment of your API, and it has a very good features in it itself. You can add a login page to protect your resources. So your login page will have a username or a password. You can add a lot of validations at your login page, which will prevent a lot of unexpected usage of that page. Then you can add security questions. So security questions are mostly used in applications like banking applications have it, or where the data privacy laws are different. So it depends on your design of your application, but security questions are also another good way to protect your application. Then you come to authentication or multi-factor authentication. So you have an option to, you may have seen sometimes you can scan a QR code, as well as you can send a one-time password to your phone or your email, so that you can add one more level of authentication to actually allow users to come into your application. Then it comes hashing or salting. So hashing is basically you have a hash function and you are passing your password to that hash function, which is a one-time process. So if once you hash the password, you cannot unhash the password. And salting is something which is recently added on top of hashing. So let's say you have two passwords who are like the same passwords by two different users. You can add a different salt. So salt is like a side of a password. There is an extra string that's a unique generated string each time. So there's a very less possibility that your the hashed password will end up the same using salting. So that's another good approach of using and defending your application. Then you have authorization, where you define your roles, your grants, and everything, so that your authenticated user are authorized to specific resources and not everything gets your way. The last thing that I really wanted to say is that whenever you give, when any of these things fail, you should never give any specific error message to a user ever. Like I've seen applications saying, okay, your username is found, but your password is wrong, which gives away a lot of information already to a hacker that, you have a valid username, and now you have mechanisms to just hack the password altogether. Otherwise, if you want this to be better, so you should give a very generic error message, so that it's like your username or your password is invalid. So that way the hacker will not be aware of what it's actually it has to find. It is either he has to find a user or it has to find a password. So that gets away the specificity of the error messages. That's very important. So let's introduce Spring Security Framework now. So Spring Security is a very powerful customizable authentication and access control framework for your Java-based application. This is the de facto standard for securing Spring-based application. Like all Spring projects, the real power of Spring Security is found in how easily it can be extended to meet custom requirements. So when we see the further slides, you'll see how easy it is to actually use the framework and just customize based on your security requirements. So like I want to add again, no two applications have the same security requirements. Sometimes you want to send your password and username into the headers. Sometimes you want to convert and generate a JWT token, or sometimes you don't even want anything to save in your application, any password to be saved in your application, and you want to use OpenID Connect with OAuth 2. So no two applications have the same usage, but Spring Security is very, very customizable. So you can do anything and everything you want. And that's why we want to explore the interfaces so that you can actually meet your custom requirements if you want to. So then why use Spring Security? It has a very easy integration with Spring Boot. A lot of applications are using, if you are familiar with Spring Boot, it's very easy to integrate with. It is being supported by a very large open source community. So one of the projects on Spring Security, I think it's the authorization server, was built entirely by this open source community. And now it's actually in production and versionized. So that's how highly supported it is. It's very famous. The authentication and authorization comes out of the box. So all these standards of security, when you plug in your Spring Security to your Spring Boot app, it all comes to you right within, and you don't have to actually write anything. I remember the time when I had to write authentication and authorization framework like 10, 15 years ago. It was horrible at that point. So I was really happy to see that it's not a problem anymore. So it's an application layer framework. Best thing that it's not tied to any web server. So you don't have to think about, okay, is it compatible with HTTP server or Apache or anything or all? It's just automatically works with any application layer. It's a loosely coupled. So that's why it's loosely coupled. You can plug in, plug out easily. It's very easy to use. It has a filter entry point with servlet. I'll show in the next slides. I have 2 slides just to show you how many filters it has in the application. Then it has multiple authentication models. Like I said before, you can use OAuth or you can use database models, whatever you want to authenticate with, it will allow you to. Then at the end, it protects you from the common security threats. And that's something that I'm very happy about, that I'll show you. Last but not the least, due to the increased adoption of this frameworks like Spring Security, many of the commonly famous exploits like cross-site request forgery, clickjacking, and some of the more common ones are no longer on the OWASP list. So OWASP is Open Web Application Security Projects. It's an open source project, and it contains the top 10 security threats. It maintains these top 10 threats so that the applications are aware, and it's very nice. It's a nice website, actually. I'll have the link at the end of the presentation. So you should be aware of these threats, and it's all written and maintained there. So that's one thing to check out. So now let's see how Spring Security integrates. So it integrates well with many things. It has a web integration. It integrates well if you want to save your passwords or users in your own database. It has a central authentication service as well, CAS, which works with the single sign-on. It has integration with OAuth as well, and LDAP can be also used. And it also being used with web services. So that's, again, a possibility. So how you want to use your Spring Security in your application? I'll tell you, the next slide is the easiest integration of all. You just have to add this dependency in your POM XML in your Spring Boot project. And if you see it clearly, it has no version number because all the versions are maintained with Spring Boot projects. So one of the best thing is that you don't even have to upgrade Spring Security all by yourself. Your Spring Boot project, once it's upgraded, it will automatically upgrade the Spring Security as well. This is the one of the best features that I've thought about using, why you want to use Spring Security. So how Spring Security works, this is getting interesting. So now we see how we have a client, which is a web browser on the left side. It sends an HTTPS request to your server. And on the right side, you see you have servlets, and the servlets are handled by the dispatcher servlet. So if you use Spring Boot or Spring Framework, you may have heard about the dispatcher servlet already. So dispatcher servlet is your starting point for your Spring applications. And what Spring Security is doing, it's adding a lot of filters before these dispatcher servlet, and your servlets are actually protected. And if you see, it's not just one filter, it's actually multiple filters here. So your request goes through the delegating filter proxy first, and then at the end, a lot of magic happens, which I'll show you in the next slide. And then it goes to the servlets. So that's why it's a lot of protection before it actually executes your servlet. So how Spring Security works, to enable Spring Security, you will have to register your Spring Security filter, which is the delegating filter proxy with your servlet container. I'm not talking about the Docker container. It's a servlet container which runs within your app server. The delegating filter proxy will forward all the requests to Spring Security filters. And these Spring Security filters have a filter chain as well. And these filter chain will perform the authentication and authorization checks. Two important things to kickstart your framework is the dispatcher servlet and the delegating filter proxy. These are the two important files or interfaces that actually kickstart your security. So in the expanded version, once the delegating filter proxy gets the request and it transfers it to filter proxy chain, you see a lot of filters are executed. So this one complete block is Spring Security filters. And these filters, each one has its own role. And it's not just one. You may have a possibility of having multiple Spring Security filters, and we'll see that in the next slide. But before that, let's talk about filters. So filter is actually, this interface is already provided to you by the Servlet API. It's nothing new at all. You have three methods here: init, do filter, and destroy. So init method is called when a web container it's called by the web container to indicate the filter is being placed into service. The destroy does the opposite. It is called by the web container to indicate when the filter that is being taken out of the service. The interesting thing is happening with the do filter. If you see the request here, the method signature here, it has the request object, a servlet request object, a servlet response object, and it has a filter chain object. So the filter chain object is doing what the next request is going to receive. So it will pass into the next filter. So which is, once your filter is executed, you know it's a chain, so it will pass to the next filter, and with the same request and response. That's what it's doing. So we looked at this. The filter chain is passed into this method that allows filter to pass on the request and response to the next entity in the chain. That's very important. So now you have filter chain proxy and a security filter chain. So delegating filter proxy delegates the request to filter chain proxy. That's the first thing, that when the request was given, and which I will call it FCP. The FCP in turn delegates to another object, which is the security filter chain. This is a wrapper around the Spring filters that will perform all your security tasks. So this wrapper has a lot of filters, and that will perform your authentication, authorization, and everything. So when your request comes in, your FCP will iterate through the SFC in the order to find the one which matches the current URL, the request URL. So your SFC is actually depending on your URL. So if you have different URLs in your application, you can have a different order, and the order is actually very important. And I'll show in the next slide what the order of this means. By default, the order is set as 100. So if you have multiple URLs and you want to have multiple with different URL, you want to have a different order. Like, let's say you want /admin to be executed before /users, which is how you should do. So you can change the order to make it order at the rate, using annotation at the rate order 99 in your security configurations, and by default keeping the other one as 100. And there are other strategies as well. So the option is to have the reason why you want to have a different SFC in your application is, first, you will have different URLs. You may have different URLs. You may want to actually have a different type of authentication authorization to be used. Let's say I have a /admin. I want to use it with my database, saving my users in the database, but I don't want to save the users in my own database. I want to authenticate with maybe Facebook or Google or something. So I'm not storing their passwords in my application. That's also a possibility with using multiple SFCs in one single application. So that's how extendable it is. So the security filter chain, again, has a matches method, which takes up the request, HTTP servlet request, and it will give you, based on the matched URL, let's say /admin or /user, it will give you which filters to execute. And an important point to note here is that you don't have to worry about which filters have to be executed, and we'll see that in an example with the code as well. It is all auto-configured. So the matches method will return Boolean to check if the request matches the filter chain, and the get filters returns a list of security filters for the matched request. That's what we discussed. Okay. So now that's what I was telling you about the filter chain proxy, and this 3 blocks here is the SFC, the security filter chain. So each box has a different set of filters to be executed, and they match based on the URL here. And when they match the URL, they execute certain tasks, and they have to do a lot of things. And the order is defined by you. So you can define the order, and you should define the order. Let's say if you want to have a better secured application, the /** should be the last to be executed, because that's something that you want to do by default. So that's a thinker. So let's see what the authentication flow looks like. So the authentication filter now creates an authentication request, and this authentication request is passed to the authentication manager. And you know what the manager does? He delegates. That's the best thing that a manager should do. So a manager delegates to the authentication provider. The authentication provider will use the user details service, and this user details service is a Spring class. So you don't have to even write the user details. So user details will load the user details service will load the user details. Again, this is a model from Spring Security, and it will return you the authenticated principal. So the authentication filter will set the authentication in the security context. So it stores, once the authentication is done, it will store the authentication in the security context. And we'll see that in the diagram here. So if you see here, authentication filter will generate the request, and then it will authenticate with the authentication manager. The manager will delegate to a provider, and the provider can be any different type. It can be LDAP provider, it can be database as well, it can be cloud provider as well. It uses the get user details method from user details service to actually authenticate if the user is right user or not. If it gets it, the end result is that the security context holder gets the security context, and the context stores the authentication principal. That's how the authentication works. So we talked about the authentication. It saves the authentication object. So what is the authentication object all about? The authentication object has a principal. It identifies the user when authenticating with username or password. This is often an instance of user details. So user details is the object that we receive from Spring Security. Credentials is obviously it's a password. In many cases, it is cleared after the user is authenticated to ensure it is not leaked. So you should not be like debugging the application and reading through the credentials. That's not how Spring Security want you to find out the passwords. They don't trust you as well. That's a good thing. And then you have authorities. That's the granted authorities at a high level permissions the user is granted. So you have roles and you have scopes. If it's a role user or if it's a role admin, you can also define groups where you can, if you have a particular URL, you want to give access to that to a specific group, a URL access. So that's also comes under granted authorities in that sense. So authentication objects look like this. It extends the principal object and it's serializable. It has get authorities, get credentials, get details. Details can be anything about the authentication request. Principal will identify who's the principal, and it has a is authenticated method. So anytime during the application running, you can actually check if it's an authenticated user or not. And then you have a set method, which actually changes the authentication, and it sets the is authenticated Boolean here. So that's how. Then you have the authorization flow. So now we have done with the authentication. So let's look at the authorization. So authorization has filter security interceptor, which obtains the security metadata by matching the current request. So different requests may have different authorization, and that's why we are really talking about the matching of the request. Then you have a filter security interceptor, which gets the current authentication. The authentication security metadata and request is passed through the access decision manager. And again, the decision manager delegates to the access decision voters for actual decisioning. The manager does. That's how it does. So what happens when there is an exception? So when there's an access denied for current authentication, the exception translation filter will delegate to the access denied handler, and it will return an HTTP 403 status code. So if you don't know, HTTP 403 is the standard HTTP code for access denied. The other codes are HTTP 200 or 200 series or something like that, but this is specific for access denied. So that's what it has to return. When the current authentication is anonymous, the exception translation filter delegates to the authentication entry point to start the authentication process. So now it's like you are going into the application. So this slide is actually where I wanted to show you all about the filters that we have seen so far. So I'm not going to go into each one of them, but I wanted to show you in regards to what all is provided by Spring Security. And it's just doing a lot of things. So there's a separate filter for logout, which handles the logout and clears up your sessions. There's a CSRF filter, there's a course filter, and you see there's an OAuth 2 as well. There's SAML authentication as well. So if you have SAML in your application, you're authenticating using SAML. That's also provided with Spring Security, and others are as well there. CAS and OAuth 2. And this is not just the end, because I have the next slide, which has another one. So in total, there are 32 filters who are doing a lot of work for us, which we don't really appreciate. So that's why I wanted to put that in the slide here. So now let's look at the common security threats that we talked about. So the number one threat that we know is injection. So injection can be any form of injection, which is a data injection, a NoSQL or a SQL injection, where a hacker or a malicious user is trying to trying to run a script which can expose your internal details. Like it can run a database query through a text field search. That's not a good way to handle the application, but that's a very dangerous thing to do. You have broken authentication. So broken authentication, if you don't manage your sessions very well, which I'm so glad that we don't have to do that anymore. I remember 10 years ago when I was handling the session management thing all by myself, which was horrible, painful. But yeah, so if you don't handle your sessions very well, you are probably allowing hackers to steal your identity. And if you are like a privileged user in your application, you will really compromise the entirety of your application. So that's again a very bad example to do. Then you have sensitive data exposure. So values like credit card or your socials are very secure, and they should be handled properly, and they should be checked properly. So when your data transfers from your client or your browser to the server, it should be checked if it's not changed anywhere in between. So like things like using HTTP instead of HTTPS is also like, adding this to the problems here. XML external entities, these are basically for legacy, some of the legacy applications. When you are executing external entities in your XML documents, there's a possibility of inserting scripts within the XML documents, or maybe inserting some malicious path to a server. That may compromise, that may also result into denial of services as well. So that's not a good idea. Then broken access control, again, if I get if I have not implemented the authorization well, even if I have a good authentication mechanism, I'm probably giving access to a lot of things in my application which I shouldn't. And that's not a good idea, because I may change things unexpectedly, and I may break things unexpectedly. So that's a very important security threat. Security misconfiguration, the one of the most common examples is I've seen a lot of developers blindly disabling CSRF, which is not a good practice. Just understand the configurations for security before you disable or enable things, just to make it work. So that's again important thing to consider. Cross-site scripting, again, when you're not validating your user input, and the user can execute enter scripts, which will, when the HTML page is rendered, they may be executing a script or alerts or things like that, which is not a good idea. And this may lead into a lot of unintentional changes in your application, and which you don't want the user interface to have that. Insecure deserialization, again, insecure deserialization can result in remote code invocation. And also, like, let's say you have a banking application, or you are on a shopping website, you are purchasing something with $20, and when your request reaches the server, the data is changed because you haven't implemented the deserialization properly, and the server doesn't know that the data was changed, and on the way the data gets changed and it's $100. That's the kind of way insecure deserialization might work. And it also, while getting the result, while getting the request coming to the server, if the result is changed, if the request is changed, you may have the denial of service as well. Somebody can deny you of the request altogether. Using components with known vulnerabilities. So whenever you add any third-party libraries, you're also including their vulnerabilities in your application. So again, it's also one of the common security threats. And you'll see one of the reasons why a lot of open source libraries that you use on your day-to-day basis, they try to keep their security levels up to date, because a lot of folks are using it, and then it lies a lot of responsibility of maintaining it as well. At the end, it's insufficient logging and monitoring. It's probably not a good idea that your users start complaining that your application is not working and you don't have the logs about it. And again, even if you have the logs about it, you're not monitoring it, and you're just waiting for the users to come back. That's again a security threat. So your application may be compromised yesterday, and you get to know about what happened in your application like 2 days after, which is not a good idea in terms of security threats. A lot of things may be compromised in between. So we talked about the security threats, and we'll see how Spring Security protects against almost all the threats that we've discussed here so far. So this is a standard Spring Security headers that we get when you execute a request using Spring Security Framework. And there's a lot going on in this one particular header, and I'll talk about this in detail. So the first thing is disable the browser cache. So you see here it says no cache, no store, max 8.0, must revalidate. So Spring is telling the browser that it should not store anything in the cache. And if your application is using a cache, it will back away. But this is like by default, Spring Security is telling your application, your browser to be specific, not to do. So all these are instructions to the browser to handle the common threats. Then it disables content sniffing. Content sniffing is actually, if you see this here, no sniff X content time options. This is very interesting because the browser is very smart. So it tries to identify what type of content it has. So let's say if a malicious user has entered any script here, it will try to identify the content type and it will try to execute it. So if you want to prevent these things by default, which you should, it's giving you directions. Spring Security is giving directions to the browser to not to sniff the stuff and just be explicit with whatever is being given to you. It disables frame, prevents clickjacking. So clickjacking is disabling the iframe. So if you see here, X-frame options deny, that's what clickjacking is doing. So that's how it is preventing clickjacking. So iframes are invisible frames. So let's say you are accessing your application, you are entering your credentials and you hit submit button, you click on submit button, and you don't see the frame, but it's an invisible frame and your hacker is able to get your credentials through that. So if you use Spring Security Framework, it's by default not allowing any X frames to be included. So that's one of the very big thing with Spring Security that it's doing. It also has an HTTP strict transport security policy, HSTS, which instructs the browsers to treat this domain and subdomains as HSTS for a year for default. So if you see here now, strict transport security. So what happens is when you type in a URL on your browser, you're not necessarily typing https:// and something google.com or something. You always try to type the google.com, you know. So at times, if you're not instructing the browser, it may happen that it starts with HTTP, the request transfers to HTTPS. But then if you're using Spring Security applications, then it's directing the browser not to actually use HTTP at all and include the subdomains as well, so that, you know, there is no man in the middle attacks possible here, because that your application is insecure when it's transitioning from HTTP to HTTPS. That's very secure. It also protects the reflexive cross-site scripting. The cross-site scripting attacks can also be prevented by handling in using, like, instead of using JDBC, use data JPA, things like that, where you don't expose the sequels in your code. It's all interface based, but it also has a reflexive cross-site scripting prevention by using this XSS protection mode block, which is a very silent way of doing it, but it's still there, which is a nice feature to have. So let's talk about the CSRF protection as well. The cross-site request forgery is an attack that forces a user to execute unwanted actions if in the application they are currently logged into. So if you're a normal user and you are using your application, you're logged into application, your cross-site request forgery can actually hack into your account. And if you are a normal user, it can state change your request, transfer your funds, change your email address, and do anything they like. And also, like, if you are an elevated user, if you have higher privileges or authorizations, or an admin user, let's say you are, a CSRF can also compromise the entire application. So it's a very dangerous way to implement it. It's a very dangerous attack. So Spring Security uses a synchronizer token pattern where along with creating a session cookie, it also creates the CSRF token, which a malicious site cannot access or use. So the reason I was telling you why don't disable the CSRF unless you are very sure of your application that the request coming from is because that it's being checked in the application when it's run. It is expecting the CSRF token from the UI, from the browser, along with your session cookie, which gets generated, the session which gets generated. So Spring Security is actually being vigilant because J session can be hacked, but CSRF token are different. So that's not easy to hack. So on the backend side, CSRF filter, again, the filter is coming into picture. The CSRF filter expects this token along with state changing request to allow the request to pass through. Otherwise, it will start to block. So these are like automatically done for you and you don't have to even do it. So example of configuring this is you'll often see all the configurations are done using a different class. If you can implement your class, a config class, which extends the web security configurer adapter, and you should enable web security. You can override configure method, and this configure method uses HTTP security. So all the changes you want to do on HTTP object can be done here. And if you notice it, this is actually a common pattern in all the Spring Security applications, and you can customize it based on your consideration. So the CSRF token repository will actually enable the CSRF tokens, and it will also check if it's an HTTPS request. So that's another way of protecting your applications as well. So the next one is HTTP verb tampering, which is an attack that exploits vulnerabilities in HTTP verb, also known as HTTP method, authentication and access control mechanism. So many authentication mechanisms only limit access to most common HTTP methods, thus allowing unauthorized access to restricted resources by HTTP methods. So if you have an application where you have given access to get methods, you can restrict access to delete or post methods. So you can allow only certain methods to be used for a one URL. So let's say if you have /users get ID exposed into your UI, you may want to restrict delete methods to be allowed. So if accidentally somebody or if a malicious user is trying to run a delete on the same URL, because the API designs we follow is the delete will have the same URL as get or post or put, you may want to still restrict that one. So that's a one way to restrict your allowed HTTP methods by setting up in the firewall, in the strict HTTP firewall class. Then you enable the content security policy to prevent cross-site scripting attacks. This is an added layer of security that helps mitigate cross-site scripting and data injection attacks. To enable this, you need to configure your app to return a content security policy header. You can also use the HTTP, this tag in your HTML page, which can direct the application to prevent cross-site scripting. Whatever attacks it can prevent by sensing it, it will prevent it. And this is again in the security config. You can also add this in this content security policy here for prevention. The next one is session fixation. So the session fixation attacks is a potential risk where it is possible that the malicious attacker is trying to create the session by accessing a site, then persuade another user to log in with the same session. So your session ID is hacked somehow. So if you are a valid user with a valid session ID, you are logged in, it can try to steal the session ID. So it's fixating on the session. It has already knowledge of that valid user. So Spring Security protects again this by automatically creating a new session, or it will otherwise change the existing session ID when the user logs in. So once the user is logged in, the session ID is actually irrelevant to Spring Security. So they want to change the session ID so that no other user who's trying to access the application can use the existing one, which was created when the user tried to log in. That's a good way. Again, the last one is enforcing HTTPS in production and not HTTP at all. So you can actually block any requests that are sent to your application by configuring again your HTTP object, which requires channel, and any requests will be, so all the HTTP requests will be blocked and HTTPS will be served only. So we covered all this, and now it's time to look at the basic authentication. So basic authentication is pretty simple. Your credentials are transmitted through headers. The header name will be authentication. Your header value will be basic plus base 64 encoding with username : password. And this is the example. We have been using basic authentication for a while, so we are quite aware of this. But what are the challenges with basic authentication? So base 64, first of all, is easy to decode. So whenever if you capture the header, you can easily decode what the user and the password was, which is a biggest threat, because once it's compromised, your entire application is compromised here. So that's one of the biggest risks, and we'll solve that problem in a while. But trying to understand the managing your password hash with application data is again a bottleneck. So again, when you're storing passwords in your application, it's not a good practice at all, because you're making yourself vulnerable to have that. Let's say, for an example, you don't want to store a lot of cash in your house. You want to go and deposit all the cash into the bank. So that's the best way, best analogy I would try to frame it here. Not trying to save passwords in your application is the best thing. Again, then sharing username and password for integrating with third-party vendors can cause a lot of problems here. So now you have username and passwords, but you want to obviously integrate with third-party vendors, and then you have to share the username and password, which again brings a lot of problems, which is risky. You don't trust the third-party vendors. How well do you know them? So it's not really a good possible solution. Plus, it's not even your username and password that you should be sharing. I feel like this is like violating your privacy and giving away your data to another application. In case of distributed application, while scaling up, you have to scale up the identity and authentication mechanisms as well. So let's say you are storing your passwords in your application. So when you are in a distributed environment, you are obviously scaling it up. So think about it. If I'm saying that your application storing passwords in your application is a bottleneck, multiplicating it is again a bigger problem, because now you are storing your password in one data center, you are cloning it in another data center, which is making it easier and easier to hack. So that's again a challenge here. So whenever you are starting from a monolith application and you're going further down into microservices, you will have to manage your authentication and authorization for each of the services. It's a growing problem in my opinion. So we're trying to solve this problem by using OAuth 2 and OpenID Connect and with the JWT tokens. So we'll see what is the goal here. So OAuth 2, the goal was mainly driven because the applications realized that the user and password sharing with multiple unknown apps was a big security threat. So you don't want to share your username and passwords, your Google username and passwords with Yelp just to log in. And that used to happen a few years ago, which is, I don't know why they wanted to do that, but there was no solution back then. But we wanted to solve this problem. And the goal is to allow the applications to access the data from third-party vendors without the users sharing their passwords. So again, the need is to protect your passwords, not having to share a lot of user passwords within the applications. And again, the problem while implementing single sign-on because of the need to share passwords within the application. So when you are implementing a single sign-on for your applications, you really don't want to share the passwords in one application to another. You want to have a single entity which has everything, which stores your password somewhere. So OAuth 2 is actually an industry standard protocol for authorization. It's again, it's not an authentication framework, but it's a protocol for authorization. OAuth 1.0 was published in December 2007. It uses scope to define permissions, what actions an authorized user can perform. However, OAuth 2.2 is not an authentication protocol, like I said, and it provides no information about the authenticated user. So what you're really getting is you still have to find out if the user is authenticated. So you may have to authenticate against LDAP, or you have to authenticate against database or something, and so on. By the way, I've not added this, but OAuth 2.1 is also coming out. It's in the draft status, but a lot of information. It's a refinement of OAuth 2.0. That's why they haven't really named it OAuth 3.0, and it's still 2.1 because it's a refinement, and it should come out. I don't know when, but soon, I hope. And I like this website, auth0.com. It's very useful, and I had all the relevant information here, so I really recommend this. So now we know that OAuth 2 will not give you the user, so you still have to authenticate against something. So what came on is OAuth OpenID Connect. So OpenID Connect is an OAuth 2 extension that will provide you the user information. It adds an ID token in addition to access token. So the access token was generated by OAuth 2, and the ID token is generated by OpenID Connect, which has a /user info endpoint that you can get additional information from. It also adds the endpoint discovery feature and the dynamic client registration feature. So we talked about tokens. So what are the tokens? So we'll talk about JSON Web Token or JOT tokens. It's a lightweight token. It has a JSON map information. You can verify it. It can be digitally signed and base64 URL encoded. It is protocol agnostic. So this is one of the best things. It can be used standalone. It can be used by many companies. Google can issue a JOT token. Facebook can issue a JOT token. And the content may be different, but a template is the same. So that's why it's also protocol agnostic. So before that, you had Kerberos, which was working differently. SAML was working differently. And that's all, they have worked very hard on trying to simplify and generalize everything. One of the important feature, I think, is the expiration time. So even if with basic auth, like we saw, once you are able to decode the headers, your application is really gone. Like your application is compromised. So if a hacker gets your headers, he will get your user and password, and your application cannot be protected. You have to really do something then. But in case of JSON Web Tokens, it gives you some bit of advantage because it's a token, so it has some values, but it also has an expiration time. So unless you set the expiration time to be like 100 years or end of the time, you really have a benefit of, if your token gets stolen, you can restrict after a certain time. So it all depends on your application usability and how frequently are you creating web tokens, but you can set up an expiration time so that your application is not really compromised once your token is stolen. Again, the JSON structure is very simple that I talked about. It's a template. It has a header, it has a payload, and it has a signature. So your payload has different values. So the fields that payload has, it's IAT, which indicates the token when it was issued at. JIT is your JSON token ID. ISS is your issuer of the token. EXP is your expiry time here. And sub is your subject, and odd is your audience here. So let's see the example of a token, how it works. So this one is a token which is authenticating against an identity provider like an LDAP provider. It generates the JWT with the user info map because the LDAP is able to tell you what the user is, and now it has authenticated everything, and the user is able to access the application on the right side. So now let's see the auth to authorization code grant. So let's say before we start looking at this, there are few terms that you should understand. It's a little different terminology being used here. So the client that you see on the right side is actually your application, and it's not the browser or your user who's actually accessing the application, which I thought was really different that what we have been used to, because it creates a client relationship between an auth server. So let's say you want to have your users log in using Facebook. So your application has to create a trust relationship with Facebook before any user can use your application using Facebook. So you have a client ID and secret. And the reason I told you like client ID is not you, but client ID is your application uh, who's actually establishing a trust relationship before that. So you have to create a client ID and a secret. You need to have that with you when you are doing that. Then you have an authorization server. So your authorization service is actually like Facebook is authenticating, authorizing who you are, and it will give you all the information. So when you sign in with Facebook, it will redirect to Facebook with client ID, and then it will sign in with you will sign in with your Facebook, and your request will be authorized, and it will generate an auth token, and your auth token will be forwarded to your application. And at the end, you will get your application when you'll get to access your application. So there's a lot of things going on, but the important point to remember is you are the resource owner. When I say you, it means the your users of your applications, and not you per se. When you are an application, you are the client again. So that's a different terminology. So that's one of the confusing things I've thought about when we were understanding the OAuth 2 and OpenID Connect things. So similarly, very similar way, OIDC authorization code flow. So when you are signing in into Yelp, you want to connect it with Google. So the URL has, so OIDC adds scope to your application. So you're trying to identify who the user is. So when you're trying to find out who the user is, you may have seen in some pop-up applications when you're signing in with Google or Facebook, you see it tells you what scope you are giving it to, what permissions you're giving it to. You're giving access to photographs, or you're giving access to your email, your birth dates, or a lot of things like that. So you can change the scope at times. So this is important to understand, because you don't want to give away everything in your application. Like you don't want to expose a lot of details of your users, only things that are required. So your authorization server is your Google account, because you're connecting using Google, and it will request for your consent from resource owner. Resource owner is basically the user who's trying to log in using Google, and then it will redirect back using callback. So there's a callback as well. So once the request is done, everything is done correctly, you have to provide a callback to your Google authorization server. So two things to remember: there's a trust relationship. So you have a client ID, you have a secret, you need to have a redirect URL where you are redirecting to. Redirecting is done back to your application, and you need to have a authorization server, so issuer server, who's actually going to authorize everything and give you back all the results. So now let's look at the code. I've given I'll give the URL of the code as well, but I want to show the code first. So I have a simple Maven application. Let's look at the application first. If you see the POM here, I have I'm using the Spring Boot starter security. I'm running on Java 16. I can't run right now on 17, but with 16 it works. So I'm going to stick to that right now. I'm using Okta as my authorization server. So again, like in the previous slides we talked about, I can also use Facebook. I can also use Google. There are other ways to authenticate as well. But I have an account. I have a trust relationship created with Okta. So I'm going to use Okta here to really show you how I can get back my user without even using any database in my application. So I've not added any LDAP or any database or any H2 database in my application. And I want to show you how I can get the user back from Okta once I log in. So just to mention a few more dependencies here, the Okta starter is also here as a dependency. Timeleave I'm using just for UI, a few points on UI, and my application is using the web starter web. So this is all maintained by Spring Boot. So Spring Boot version you can see here is added in the parent 2.5.4. So that's my application. I'll also show you the controller that I'm going to use. So I'm using something called as method injection. So I'm injecting my OIDC user here in my slash URL here with the model, and I'll set the model, which the model will be returned or populated once I get all the information. So the URL, the web page should receive the model as well. So that's one. And I don't want to show you my exact user issuer ID and secrets, but these are the properties that you will need to define. So you need to have an issuer from Okta. So once you create your application portfolio and everything on Okta, you will get an issuer ID, issuer URL to be precise. You'll get a client ID and you'll get a client secret. And then again, once you are done, you will have to define where to redirect back. So I'm doing it back to a localhost 8080, and I've interesting things to show here. So that's why I've enabled the logs here. So let me start the application and we'll see in the logs what's happening really. So if you see here, I've enabled the trace log, which I don't think you need to do that, but I wanted to show you the filters that will run here when you start your application. So right now it's started it. Let me run this localhost. So if you see here, it redirected me directly to the Okta login page. I didn't even have to do that. And once I sign in, I get my name back, and I have not configured the HTTP H2 database or any application. So my user is traced back. If you see here, there are a lot of filters executed. So 1 out of 18, it's invoking web async manager, Spring context persistence filter, CSRF filter, header writer filter, and there must be somewhere OAuth 2 related filter as well. So it's doing a lot of things that is being done by one filter. So it matches the URL and it executes a lot of filters based on the URL. So that's why what we were talking about. So I think that's for the demo. Let me go back to my presentation again, and I'll share the link on the chat once I'm done. So hold on for that, or you can find it on my GitHub repo. So I want to end this presentation now with the principles of security. So initially when I presented in, I think in the month of March at New Jersey conference, I actually mentioned the principles before, but I like to end this on a positive note and some learnings once you are finished learning all about what happened really. So you want to minimize your attack surface area. So let's see what it really means. So minimizing your attack surface area means when you add a new feature, you have to be careful what you're allowing your users to do. if you add a lot of search features in your applications on your web page, you're actually exposing yourself to have, the users to be able to do multiple things, and you don't have a control of that. So that's why you may have seen a lot of times on web pages, you don't see a lot of search or text boxes. You have like pickup options or radio buttons or all these things. That's a good UI design that tells you. Establish secure defaults. So like I said, you want to secure your application by default, and that's why when you just add your Spring Boot dependency in your Spring security dependency in your Spring Boot application, your application is secured by default. So you don't want to have to add security at the end. You want to start with a default secured application. That's another thing. Then principle of least privilege. I work in a bank, so I always follow this principle. Don't give access to anyone unless it's required. If they ask for it, give them the privilege, but you don't have to make all the users as admin users. So try to avoid that mindset of giving away access to everyone. That's really difficult to manage design, and it allows a lot of people to hack into your application or do unexpected things. Then allow the principle of defense in depth. I've seen at times a lot of applications, they say, will put everything, all the validations, will put that at the backend layer. We don't want to validate anything on the UI layer, which I don't think it's a good idea, because you want to protect your application at each layer. So again, a castle building approach is preferred over you let the UI do whatever they want, and then at the end, when the request comes to backend, you have to solve everything. So that's not a good way to design your application. Then fail securely. This is again, you may have seen sometimes when your some applications, they fail, they give away the web server or app server information, like Tomcat exceptions. I've seen in few applications over internet. It's really not a good idea to disclose anything. So you want your applications to fail securely and not unexpectedly giving you all the informations as a user of your application. That's not a good idea. Don't trust services. Whenever you add any third-party services, do not just blindly add them. You have to do some research work. What are the services? What are the security mechanisms of those dependencies that you are adding, so that you don't really give away everything? Because you may have a secured application, but if your services, that third-party services that you're using, are not secured, then you are really making yourself open to attacks. Then there's separation of duties. It's a very it's a good concept, because let's say you have a user from e-commerce, and they are trying to become an admin of your application, of your shopping application. You want to ask who is allowed to do what. So whenever you are trying to design and decide what authorizations you want to give, you want to really separate the duties of your users. That's important thing to understand. Then avoid security by obscurity. It's very simple saying that I've seen people having a URL and they have a username, admin users, URLs having admin as user and password, and they say, okay, this is not mentioned in any documentation. Can we just it's not shown anywhere, so can we just keep using it because it's easy to use? That's not how the internet works, because the hackers are trying to hack this very logic every time. So you don't want to just say that you can avoid security by just obscuring it. So that's not a good way to do it. And then keeping security simple, like I showed in my application, I just had 2 lines of code, and I was able to get securely my user details and anything I required on the user. So you should be able to do security very simply. You don't want to complicate your security by using sophisticated methods and anything and everything, because ultimately you want to focus on your applications. Your business logic is important, your innovation is important, so you don't want to have to manage security a lot. So that's why keeping it simple is also a good idea, and using Spring Security is actually one of the best things that you can do with keeping it simple. And then fix security issues correctly. Like I said, if you don't understand a security defect, you're not trying to fix it correctly. So you have to understand what the security issues are coming, and you have to act accordingly and not just blindly do things like, okay, let's just fix things and move on and we'll see what happens at the end. So uh, don't do that ever. So that's what my point is. And I have some references here which I used, some references on Spring Security as well, and some design principle. I've also used the design principles and the OWASP top 10 list, which is very good and it's nicely updated. So that's what I'm gonna do. So handing it back to Mike and the guys.
Okay, Neha, thank you very much. So first of all, I want to remind everybody, if you're interested in winning a license to IntelliJ IDEA for 1 year, please enter your name and email address in the Google spreadsheet that we have available. I don't know if it was reprinted on the chat. If somebody could do that on the YouTube side.
It's
I'd
in the
appreciate it.
chat, and if somebody needs to see it again, they can scroll upward.
Yeah. So while we're allowing people to do that, first, I want to ask a question. I know Spring One was just 2 weeks ago, and just wondering, Neha, about the upcoming. Well, they had a roadmap for Spring Framework 6 and Spring Boot 3, which aren't expected to be released until a year from now. But from what I understand, it's going to require JDK 17, which will, be a non-issue by then because it'll be JDK 19 by, a year from now. They're gonna build in observability, drop some outdated features, and then last but certainly not least, JEP 4.11, which was included in Java 17 today, is deprecating the security manager. Now, from what I've read, it hasn't been used all that much. Whatever, there seems to be a lot of buzz about it in terms of Jakarta EE support and whatnot. Do you know anything about like these concerns I just mentioned related to Spring Security?
We haven't talked about that in Spring Security much, but I know that they are working on making it compatible with JDK 17, which is going to be the next baseline for Spring Boot applications. So they are really trying to make it up. They have also already provided the support for Spring Native apps. So if you don't know, Spring Native is already compatible with Spring Security. And I briefly talked about OAuth 2.1 as well. So OAuth 2.1 has refined a lot of authorization grants, which I would say it was a refinement because they have removed some of the grants from 2.1, and I was reading the drafts. So that's something which Spring Security is already working on. Like I said, my information on deprecated security manager is the same, like it's not being used much, so it's marked for deprecated. So I think I don't have much knowledge apart from that right now, but I can check.
Yeah, I know it's early, but I know you were there at Spring One, and I had every intention of attending myself, but a flood at work seemed to have taken priority that week. So that's a long story in itself. But in any event, yeah, thank you. Anybody else have any questions for Neha on Spring Security? Which, by the way, very awesome presentation. Thank you very much.
Thank you.
I had a chance to mess around with Okta myself. So I have a working application just with Okta, but I don't think I use Spring Security in that. So
Okta has a developer profile. You can create almost 5 applications for free, and I really liked it. I've actually tried the Auth, OpenID Connect with Facebook as well. But with Facebook, you cannot use the local host 8080 as redirect URL. So you really have to create another token, which is like a non-production token that they enforce, which I thought was pretty neat. But it's a bit complicated than using Okta. Okta, I thought, was pretty simple and straightforward.
Yeah, so I think you can build applications, build security in applications more quickly with Okta, I think. But cool. Are there any other questions from YouTube?
I'm checking right now. I don't see any right now. Nope.
It's a lot of information.
All right.
Yeah.
Well, we're still giving folks a chance. Right now, there's only a handful of folks in the spreadsheet there. Let's just wrap up my slides over here real quick, and then we'll do the final.
I was actually happy because with Spring One, I had to finish the talk in just like 55 minutes at sharp.
Yeah.
And with you guys, I was like so relaxed. I could talk about things which I wanted to.
Yeah, I know that's the thing with time limits on some of these presentations. You have to decide which slides to cut and all that stuff. So just to wrap things up, we got some upcoming events. As you can see, there are InfoQ lives. This is something new that ever since the pandemic hit, because obviously couldn't have any QCon in person events, and so these are like a day of just one day with maybe 3 or 4 talks. Next one is in September 21st, and then there's one in October, and then there is InfoQ Plus, I think, for November, which I didn't add on here, but there's the JCon Online Conference on October 5th through the 8th. As members of the Garden State Java user group, we were like I guess a supporter, or I guess a partner of this conference, and you're entitled to free tickets. I think it's a $99 value. I will send another email with the code in order to register for this. And then of course there's EclipseCon 2021, which is at the end of October. There's always a lot of good talks scheduled for that. Then there's some upcoming meetings. As I mentioned earlier, the FUJE Open JDK 17 Plus JUG tour, and I mentioned already that Simon Ritter will be presenting our all Open JDK builds created equal. And as you know, I mean, you have Azul, you have Bellsoft, and we have a number of others, Amazon Corretto, that have their own downstream distribution of Open JDK. And then on Tuesday, October 12th, we have Dan Moore, who's going to talk about Java Web Tokens, which Neha mentioned in her presentation. I was at Code One, and David Blevins, the CEO of Tommy Tribe, gave a great talk on the basics, like a JWT 101, and it was quite interesting. So I hope we see you guys for that. I believe, well, maybe I don't know if the registration's open for that yet. And then, as I mentioned earlier, we will reschedule with Red Hat for the Quarkus World Tour, and you can get an email from me, and also the website. And so, yeah, so we're at the point to give away a license of IntelliJ IDEA, and these are the basic ground rules. And it's pretty straightforward. And they're, just so you know, they're just to avoid any confusion, there is an expiration date, but that's the expiration date for which you can redeem your license. The license is good for 1 year. So just so you know. So Barry, I don't know if you were running.
There's a question that I have in my mind. I'd like to know if there's anybody here who slays falcons. Do we have a falcon slayer here?
Well, that's slays falcons.
A falcon slayer.
A falcon slayer. Well, that's not my cup of tea.
We may have to wait 20 seconds to find out if our Falcon Slayer is in the chat.
Oh, wait, is that the person on the spreadsheet?
Yep.
I am not familiar with that term.
Let me check again. Okay, the Falcon Slayer's real name is Mickey Luffy.
Mickey, okay. And it's in the spreadsheet, right?
Here.
So awesome. Let's see. Yeah, so we've confirmed it's the Falcon Slayer is Mickey.
Yep.
Okay, great. Congratulations, Mickey. We will send you an email with a PDF file attached for that coupon that you can redeem. And it gives you information on how to do that. And as I always like to end all of my presentations, I use the same slide for, it is that time of the evening to indulge in some good craft beer. As most of you know, I'm a craft beer enthusiast. So I want to thank everybody for coming tonight. And any other questions, concerns, gripes, anything? If I'll give us I'll give you the email address for anything that you'd like to discuss with us. It's info@gsjug.org. I'd like to encourage folks, if they have a desire to present something, you can let us know. We're always looking for talks. We're trying to round out the rest of the year and into early next year for talks. So please, if you have anything, that would be awesome. All right. Anything else? Anything on chat, Barry?
We're clear.
Okay, folks. Well, thanks again. Have a good rest of your week. Check out Java 17. Also, there'll be an InfoQ news item from one of the other Java editors on the Spring Boot 3 and Spring Framework 6 coming out within the next week or so. So stay tuned for that, and we'll hope to see you on the 28th. All right. Have a good night, everybody.
Good night.